Welcome to Research Creations. This video will be covering the topic of acids and alkalis. Acids and alkalis are one of the most important classifications of substances, not only in a lab, but everywhere else in real life, as it can determine different properties of a substance and what are its suitable use cases. In this video, I will talk about what the pH scale is and how we define it, what the terms acids, alkalis, and bases mean, and neutralization reactions. Now, let's move on to the pH scale. The pH scale is a metric that we use to determine the acidity or basicity of a substance. The pH scale stands for potential hydrogen. This term comes in very important when we start to cover the terminology of acids and alkalis. The pH scale ranges from the values 0 to 14, 7 being neutral, values less than 7 being acidic, and values higher than 7 being basic. The pH scale really just measures the amount of respective free hydrogen or hydroxide ions, thus coining the name potential hydrogen. There are many different types of acids. Citric acid makes fruit taste sour. Sulfuric acid in car batteries. All acids have this one thing in common. They all produce hydrogen ions when dissolved in water, also known as H+ ions. Solutions with plenty of free H+ ions are called acidic solutions. Because of hydrogen's atomic simplicity, a H+ ion is the same as a proton. Thus, acids can be a source of protons in an experiment. Let's take hydrochloric acid for example. When hydrochloric acid is dissolved in water, it splits into its base ions, hydrogen and chloride. This process is known as ionization, which basically means acid molecule splits up into its component elemental ions when in an aqueous solution. H+ ions will always be present when an acid ionizes. All components in this ionization equation are complemented with an AQ symbol. This indicates that ionization occurred in an aqueous solution, meaning the acid is dissolved in water. Alkalis are similar to acids, as they both produce ions when dissolved in water. But instead of hydrogen ions, alkalis produce hydroxide ions, or OH- ions. These OH- ion prevalent solutions are called alkaline solutions. Alkalis are usually soluble metal hydroxides, for example sodium hydroxide and calcium hydroxide. For example, when a sodium hydroxide is dissolved in water, it separates into its base ionic components, hydroxide and sodium ions. OH- ions will always be present in an alkaline ionization. The terms alkalis and bases are easily confused upon, but there are important differences between the two that need emphasis. The word base categorizes all soluble and insoluble substances that react with acid in a neutralization reaction to form a respective salt and water, usually an insoluble metal oxide or hydroxide, whereas an alkali is just a soluble base, usually a soluble metal hydroxide. An example of a base is copper oxide. Its pH is higher than 7, but it is not an alkali, as it is insoluble in water. But it still reacts with hydrochloric acid to produce copper chloride and water. Sodium hydroxide can be considered an alkali, as it is soluble in water. Like I briefly mentioned before, neutralization reactions are when an acid and base react to form salt and water. Neutralization reactions can also be defined as hydrogen ions reacting with hydroxide ions to form water, as shown in this neutralization equation. Let's take a reaction between hydrochloric acid and sodium hydroxide, for example. An alkali with an acid. The products of these two reactions are sodium chloride and water. If we remove the spectator ions from this reaction, it will result in the same equation as mentioned previously. Water is the base product for every neutralization equation. Let's take another example, this time a base with an acid, the reaction between copper oxide and hydrochloric acid. Copper oxide is not an alkali, so it does not necessarily need to have the OH- ions in the reactants, but it does produce salt and water. In this case, copper oxide and hydrochloric acid react to produce copper chloride and water. Neutralization reactions are usually used to dilute strong acids or alkalis, and is also the base principle behind the vinegar and baking soda experiment. Here's a summary of what was covered in this video. The pH scale stands for potential hydrogen and is a metric to determine the acidity and basicity of a substance. Acids are substances with a pH lower than 7 and produce hydrogen ions through ionization when dissolved in water. Alkalis are soluble, and bases are both insoluble and soluble. Both are substances with a pH higher than 7 and produce hydroxide ions when dissolved in water. Neutralization reactions are reactions between acids and alkalis to produce salt in water.